Hello students, your teacher here, Mr. Sharasinski with another episode of Algebra. Oh no, wait, stop. I keep making this mistake. You know, when you make 120 videos in a semester, you kind of tend to say the same thing. But this is actually geometry, and this is lesson 1-4. This is Intro to Angles and the Angle Addition Postulate. And so in this lesson, lots of vocabulary. Some of it is review, like the types of angles should all be review for you. But it's something that also you should just be mindful of and pay close attention to as we work through this. So here we go. An angle is formed by two rays with a common endpoint. Okay. This common endpoint is called the vertex, and the rays are called the sides. We name an angle using 3 letters, and the middle letter must always represent the vertex. So, down here, when referring to the measure of an angle, use a lowercase m, but you can see B is in the middle because B is the vertex. Okay. Use a single letter if there is only one angle located at the vertex. So technically for this angle to the left here, we could just say angle B because there isn't more than one angle stemming off from that vertex. Okay, and when referring to the measure of an angle, we use a lowercase m in front of the angle name. All right, so there are 4 types of angles. We have acute here. And acute angles are less than 90 degrees. Okay, we have obtuse, and obtuse angles are greater than 90 degrees. And we have a right angle, and they are equal to 90 degrees. And last, we have a straight angle. And straight angles are equal to 180 degrees. All right. So here's our first example. Name the vertex of the angle. Name the sides of the angle. Give 3 ways to name the angle and classify the angle. All right. So here we go. The vertex is K. The sides of the angle are ray JK and ray KL. 3 ways to name the angle. Well, the first one is just angle K. Since it only represents one angle, we can use the vertex. The second would be angle JKL with K in the middle because it's the vertex. And the last would be angle LKJ. Again, K is the vertex, so it is in the middle. And to classify this angle, without using a protractor and actually measuring it, I can tell that this is obtuse. It is greater than 90 degrees. All right, example 2. Name the vertex of the angle. That's going to be S. Name the sides of the angle. That's going to be side RS, ray RS, and ray ST. Give 3 ways to name the angle. Well, the first one would just be angle S. And we could say angle RST, or we could say angle TSR. Okay, both of the 3-letter names have S in the middle because it is the vertex. Classify the angle. Because of this box here, I know that this is a right angle and is equal to 90 degrees. Congruent angles. If the measure of angle A is equal to the measure of angle B, then the angles are congruent. This is written as angle A is congruent to angle B. So it's like an equal sign with a little squiggly over top. And that just means that they are equal in angle measure. Okay? All right. Next page. Angle bisector. So an angle bisector is a ray that divides an angle into 2 congruent angles. In the diagram to the right, ray BD is an angle bisector. Therefore, angles ABD and angle DBC are congruent. And here I want to point something out. You see the little arc in the angles here. That shows that they're congruent. Okay? If you see those little markings in the angles, that means they're congruent in a diagram. All right. Perpendicular lines. Two lines that intersect at a right angle. The symbol for perpendicular is like an upside down capital T. In the diagram to the right, line L is perpendicular to line M. Perpendicular bisectors, a line segment or ray perpendicular to a segment at its midpoint. Okay, so perpendicular bisector just adds that little piece on that it bisects it, which means that it creates two congruent line segments. In the diagram to the right, LM is the perpendicular bisector to PQ. Okay. All right, example 3. Write another name for angle CBF. CBF here. Actually, I'm going to use my highlighter. CBF. Another way to name CBF would be FBC. We cannot use the vertex in this example because that is the vertex of multiple angles in this diagram. Name the sides of angle EBD. Okay. The sides of angle EBD are sides, let's see, we have ray EB and we have ray BD. Classify angle ABC. Angle ABC is a straight line, which means that is a straight angle. Okay. Give an example of an obtuse angle. How about angle EBD? That looks obtuse. And you could have different namings here. We could also say DBE, just renaming that angle. ABF, FBA, EBC. There's multiple examples here that would work. Name two congruent angles. All right, so this is where you need to look for those symbols that I was telling you about. And I see them right here and right here, and we'll learn why those are congruent later. But that would be angles EBA and angle CBF. Name a perpendicular bisector. Perpendicular bisector is going to be ray BD. Okay, right there, and it bisects line AC. All right, example 4. Name the vertex of angle 2. The vertex of angle 2 is T. Name the sides of angle 4. That's WT and ZT, ray WT and ray ZT. Write another name for angle 3. Another name for angle 3 would be angle UTZ or angle ZTU. Write another name for angle 1. Another name for angle 1 would be angle YT. TX, or you could also say angle XTY. Classify YTW. YTW is a right angle, and I can tell because it has the box at the vertex. Classify YTU. YTU looks to me to be obtuse. Classify XTU. XTU, that is acute. Classify WTX. WTX is a straight line. It's going to be a straight angle. And then name two perpendicular lines. So let me erase some of this mess here, and we can see our perpendicular lines. They intersect at a right angle. That's the definition of perpendicular. So that would be lines WX and YZ. And then name an angle bisector. That's going to be ray TU. And it bisects angle XTZ. And I can tell because it had those little arcs in the angles near the vertex, and that shows that those two angles are congruent. And that is how I knew that was an angle bisector. Okay, moving on. The last part of this lesson is the angle addition postulate. And the angle addition postulate says if D is in the interior of angle ABC, then angle ABD plus angle DBC equals angle ABC. Okay, very simple. This is not a bisector. Okay, we're just simply saying that because ray BD is inside angle ABC, then we can add those two angles together to equal the total angle ABC. All right, a couple examples. Use the diagram below to answer questions 1 and 2. If the measure of angle ABD is 48 and the measure of angle DBC is 78, find the measure of angle ABC. Well, if using the angle addition postulate, we can say that 48 plus 78 is equal to the measure of angle ABC. 40 plus 70 is 110. 8 plus 8 is 16. That's 126 degrees. Okay. If the measure of angle DBC is 74 and the measure of angle ABC is 119, find the measure of angle ABD. So here we have to do a little subtraction. 119 minus 74 is equal to 45 degrees. Okay. Number 3, if the measure of angle PQR is equal to 141 degrees, find each measure. All right, so we have a little algebra to do here. We're going to be solving an equation for x and then substituting x into the expression for PQS and then into the expression for SQR to find each angle measure. So we can say, based on the angle addition postulate, that 13x plus 4 plus 10x minus 1 is equal to 141. Okay. Now we need to combine like terms and start to solve. 13x plus 10x is 23x. 4 minus 1 is 3. Subtract 3 from both sides. 23x equals 138, and then divide by 23. X equals 6. Okay, so the measure of angle PQS is equal to 13 times 6 plus 4. And 13 times 6, that's 60 plus 18. 78 plus 4 is 82. 82 degrees. And then the measure of angle SQR is equal to, ran out of room. Let me go over here. I'll just go a little further down. Is equal to 10 times 6 minus 1, which is 60 minus 1, 59 degrees. Now, if we did this correctly, just to double check, 82 plus 59, 80 plus 50 is 130, 9 plus 2 is 11, 130 plus 11 is 141. So yes, those do add up to equal 141. Number 4, the measure of angle DEF is 7x plus 4, so that's the whole angle, and the measure of angle DEG is 5x plus 1. Okay, DEG, this is 5x plus 1. Oh, that's kind of messy. 5x plus 1. And the measure of angle GEF is 23 degrees. Find each measure. So a little different setup, only we're not given the total angle measure. We're given one of the supplementary angles. And so we're going to add 5x plus 1 plus 23 is equal to our total angle expression, which is 7x plus 4. Same process, except now we have to get the variable on one side before we can solve for x. Once we find x, we'll substitute it in to find DEG. And then technically all we have to do is add DEG to 23 and get DEF. So here we go. Combine like terms. 1 plus 23 is 24. Subtract 7x so we can get the variable on one side. Subtract 24 as we start to isolate the variable. Divide by -2. X equals 10. Okay. If x equals 10, then the measure of angle DEG is equal to 5 times 10 plus 1, which is 51 degrees. And the measure of angle DEF is equal to 51 degrees plus 23 degrees, which is 74 degrees. Okay. And we can also substitute it in just to double check. 7 times 10 plus 4, that's 74. So yeah, they check out. Number 5, if the measure of angle JKM is 43 degrees, JKM, so this is 43. The measure of angle MKL is 8x minus 20. And the measure of angle JKL, the whole thing, is 10x minus 11. Find each measure. Okay? So we can say 43 plus 8x minus 20 equals 10x minus 11. And combine like terms, that's going to be 8x plus 23 equals 10x minus 11. Get the variable on one side, subtract 10x from each side. Add or subtract 23 from both sides. Divide by -2. X equals 12. Okay, if x equals 12, then the measure of angle MKL is equal to 8 times 12 minus 20. That's 96 minus 20, which is 76 degrees. And then the measure of angle JKL is equal to 76 plus 43, which is 70 and 40 is 110, 6 and 3 is 9, so that's 119. If you want to double check using x, because we were given an expression for measure of angle JKL, we could say 10 times 12 minus 11. 10 times 12 is 120. 120 minus 11. Uh-oh, did I make a... Hold on a second here. Oh, I caught my mistake. All right, so this was 11, and when I was solving, I left off one of the ones. So that made a mistake when I was solving my equation here. This should have been 34. which would make my x 17. Okay, so got some answers to fix here, but it's no big deal. Mistakes happen, guys, and you know, when you make one, own it, fix it, and go on. It's not a big deal. 8 times 17 is 80 plus 56 is 136 minus 20 is 116. So this is 116 degrees. And then JKL is 116 plus 43. So that's 116 plus 43, which is 159. Okay, if you want to double check, 10 times 17 is 170 minus 11. So that's 159. Let me erase that. Sorry about the confusion, guys. Okay, next. Number 6. If angle DEF is a straight angle, that means this angle equals 180. And the measure of angle DEG is 23x minus 3. And the measure of angle GEF is 12x plus 8. Find each measure. All right, so here we go. If it's a straight angle, then we can say 23x minus 3 plus 12x plus 8 equals 180, because the definition of a straight angle is that it is equal to 180 degrees. So combine like terms, 23x plus 12x is 35x, and negative 3 plus 8 is positive 5. Okay. Subtract 5 from both sides, and 35x equals 175. Divide by 35, and x equals 5. Okay. If x equals 5, then the measure of angle DEG is equal to 23 times 5 minus 3. That's 115 minus 3, which is 112 degrees. Okay. The measure of angle GEF is equal to 12 times 5 plus 8. That is 60 plus 8, which is 68 degrees. And if we did this correctly, yeah, it better add up to 180. All right, number 7. If the measure of angle TUW is 5x plus 3, and the measure of angle WUV is 10x minus 5, and the measure of angle TUV is 17x minus 16, so they're not telling us the angle measure, but they're giving us another expression, find each measure. So here we go. 5x plus 3, we're using the angle addition postulate, okay, plus 10x minus 5 is equal to the total angle, which is represented by 17x minus 16. All right, combine like terms, that's 15x minus 2. Get the variable on one side, I'm going to subtract 17x. Okay, add 2. And divide by negative 2. So x equals 7. Now we can use 7 and substitute it into each expression to find the missing angle measures. So first we'll do TUW. The measure of angle TUW is equal to 5 times 7 plus 3. That's 35 plus 3, which is 38 degrees. Okay. The measure of angle WUV is equal to 10 times 7 minus 5. That's 70 minus 5, which is 65 degrees. And then TUV should just be the sum of those two angles, which is 90 plus 13, 103 degrees. Number 8, if the measure of angle ECD, okay, so we have to do some interpreting here. And this is always good practice. 6 less than 5 times BCE. And BCD, so this whole angle they're saying is 162. Find each measure. Well, I think it's important here to just go ahead and name the angles because we're going to be assigning algebraic expressions to them. So angle BCE, we're going to say equals x. And angle ECD is going to be 6 less than 5 times. So that'd be 5x minus 6. Less than, remember, that is a backward word phrase. When you see that and you're asked to interpret it, to write an equation or an expression, it's always reverse order. So it says 6 less than 5 times, so that's 5 times minus 6. So our equation is 5x minus 6, the angle addition postulate, plus x equals 162. So 5x plus x is 6x. Combined like terms, now add 6. 6x equals 168, and then divide by 6 on both sides. X equals 28. So if x equals 28, then the measure of angle BCE is 28, and the measure of angle ECD is equal to 5 times 28 minus 6. 5 times 20 is 100, 5 times 8 is 40, so that's 140 minus 6, which is 134 degrees. All right, last two. Use the diagram to the left to answer the questions 9 and 10. All right, so if the measure of angle ABF is equal to 6x plus 26, and the measure of angle EBF is equal to 2x minus 9, and ABE, the entire angle, is 11x minus 31, find ABF. So it's asking us to find ABF, but in order to do that, we have to find x first. So we can set up an expression. So we're saying angle ABF plus angle EBF is equal to ABE. Okay, and then I'm just going to substitute those expressions in. 6x plus 26 plus 2x minus 9 equals 11x minus 31. Combine like terms, that's 8x. 26 minus 9, 17. Okay, and then equals 11x minus 31. Subtract 11x. And negative 3x plus 17 equals negative 31. Subtract 17. Negative 3x equals negative 48. Divide by negative 3. X equals 16. So if x equals 16, then we can say the measure of angle ABF is equal to 6 times 16 plus 26. 6 times 16 is 60 plus 36, that's 96 plus 26. 90 plus 20 is 110. 6 plus 6 is 12. So that's 122 degrees. All right, last example. If BD, let me go ahead and erase my stuff from the last. If BD bisects CBE, okay, so BC is perpendicular to BA. BC is perpendicular to BA. That means this is a 90-degree angle. The measure of angle CBD is 3x plus 25. And the measure of angle DBE is 7x minus 19. Find the measure of angle ABD. Wow. Okay. All right, so I'm pretty sure this information was not necessary. But, that's part of it, navigating through these problems. This is all we needed to know. BD bisects CBE. So knowing that, we can set CBD equal to DBE. Okay, so 3x plus 25 is equal to 7x minus 19. Okay, if those are bisected, then those two angles are equivalent. Subtract 7x from both sides, get the variable on one side. Subtract 25. Negative 4x equals negative 44, and then divide by 4. X equals 11. All right, so if x equals 11, then the measure of angle ABD is equal to, oh, now I see why that information was useful. 90 plus 3 times 11 plus 25. 3 times 11 is 33. So that's 120 plus 25, which is 145 degrees. 120, 90 plus 58. Hold on a second. 33. Yeah. Oh, that's 148. All right. I'm your teacher. This is the way.